I have started the recording. So,
Okay, I think, yeah, then Deepak can proceed with the architecture diagram and we can discuss on that. Okay.
Okay, sure,
yes.
sure.
Okay.
Yeah, hi everyone.
Hi.
Okay, let me share my screen. So we have prepared two type of architecture we have prepared. So there is Kubernetes based, that is EKS, and there is another service ECS. If any one of you are like aware of or not, I'm not sure. Do anyone like worked on ECS service, Amazon native AWS ECS service? Yes, no?
On EKS, I have worked on ECS Elastic Container, something like I have not any hands-on on that.
Yeah, no issue. So we have prepared the tech stack. The developer have told us the architecture, like what all tech stack they are using, and according to that, we have prepared few diagrams. Here you can see EKS workload. uh, I'm not sure like if you guys are aware of this subnet, public subnet, private subnet or not. Are you like how much of you are comfortable with the networking part of this AWS? Yes,
Yeah,
no?
I'm familiar. Yeah, I'm familiar with multi-AZ clusters and regions, subnets and all.
Okay, rest. Don't worry, I won't ask any question. I just want to like know like if we all are in same page or not. I'll say I have to discuss that thing. Swapnil.
Yes, I'm aware, but not in the depth actually.
Okay. Uh, okay, let me. So basically, we prepared architecture diagram for two workloads, so EKS and ECS. So in this also from security concern, let's say if you deploy anything now, so your application should always be in public, sorry, private, and that application should get exposed through your uh, where is Scalidraw. Let me share. So basically, let's say you have AWS and you have created VPC. So VPC is nothing but virtual private, basically networking pool you can prepare. And there are subnets, like there are public subnet type and private subnet type. The way how you create will cover in session, but there are two kind category of subnet pool which you create. Let's say this is your private, public. So the public means whenever, so this is public. So when you create a public pool, so basically whenever you deploy any server here, na, you can directly reach out from internet. Let's say you are on internet and you are like sitting in your home and and you deployed some public server, like virtual machine here in public subnet. So you get a public IP, so you can directly use that IP and you can directly ping or get a, like into that server, so you can directly reach out to that server. But for security concern, you basically we don't do that on production. When you deploy any clusters of Kubernetes or ECS cluster, so your application should always be in private subnet, and that application will always get exposed using any kind of load balancer which get deployed in your public subnet. So that's how your routing comes. So this is, since this load balancer is in public subnet, whenever you can directly access the DNS of this load balancer and it will route your traffic to your application. So that's how you architect any application. Currently I am using this Xcali, but Escalator. Basically, you can use this draw.io. We'll discuss with Shrikant like how to assign you guys tasks. So we'll have a session on this. Draw.io. So here basically you create a there is a plugin you need to install. I'm not sure if I am install or not. So when you install that AWS specific AWS subnet, you can prepare architecture diagram from here. Look, this is public subnet, this is private subnet, and we can use this draw.io. But currently, I'm explaining the architecture, like what all two solution we came up with. So that's how you architect any application. So I have, like application should always go inside private subnet, and it should get exposed through your this load balancer, and also database too. The database should always should get deployed into private subnet. That's how if you see here, your load balancer is like deployed here in public subnet, and your EKS workload, the workload is nothing but the compute where your actually the application as a pod will be running. So here this all of your workload is in your private subnet, and also the database is in private subnet, and that's how your traffic goes from public to private. This public, so you can basically access your application from, like, let's say you are on internet or you are sitting at your home using your laptop, you can directly access your load balancer from here, and it will route your traffic to your corresponding application. So we had a discussion with the developer. I'm not sure if you guys also joined that call or not. uh, but the application they provided us is that, like, they have a front end in React JS, and back end they will be developing on Merge stack something. So probably Node.js as a back end. So every application will get deployed into this. Since their traffic will be very low, so we came up with two solutions like EKS and ECS. ECS is also diagram we have prepared. Like uh, here you can see ECS. So this is ECS. So ECS, so ECS is nothing but it is also like a Kubernetes kind of thing, but this is native to AWS. This service is not in any but in another cloud, but the naming was very different. So since the application workload will be way more lesser, so from cost perspective, because if you deploy this EKS cluster na, you also deploy nodes, worker nodes. So that worker node will, like, occupy in basically AWS. Each CPU has a hourly charges. So if you can go into the documentation, let's say T2 dot medium AWS, you can see the charges, hourly charges here associated with, like, the server from here in USD, and this is the hourly charge, and you can basically convert it to monthly. So you can convert it this into dollar or INR. You can convert. So $33 is approximately INR. Let's say Indian rupee. So here you can see monthly, if you will be using this server as a worker node, so ultimately you will be paying 3000 something rupees monthly. But in ECS service you pay, like, here you can see this is like 2 CPU and some 4 GB memory. And obviously you, if you are deploying this into Kubernetes cluster, you will be deploying multiple nodes to maintain highly available system. So but considering the scale and everything, this ECS is the service you can use. We can use this basically. But in ECS, there is another service. ECS has two kind of category. Like when you deploy any ECS cluster na, and you want to deploy any application, so basically you deploy, you can basically use this ECS service in two category. Like you can under this ECS cluster, let's say you have this ECS cluster. So into this, you can basically deploy your VM based deployment you can do. So basically, you can register any virtual machine inside this ECS, and now you can deploy your application here. But there is another service which is called ECS Fargate. Fargate type. In Fargate type, basically what you don't have to manage this virtual machine. What you will be doing is that you have application, you have containerized this application, and you provided CPU and memory configuration, and it will automatically deploy your application. You will not be managing any virtual machine, or you will not be, the virtual machine is not visible to you. So this is Fargate type, and it is way more cost optimized way considering the scale they have told us. So this is what Fargate type of ECS, and it is also auto scalable. Like if your traffic goes beyond any CPU memory limit, you can configure this to basically scale out your application, and it will basically, you have configured this application and you have provided 0.2 CPU and something 500 MB of RAM. So you can configure this if your threshold is reaching to 80% of your CPU or memory, basically scale out, and this will create another replica, and basically your load balancer will it will register the application into your load balancer, and it will, there are configuration you have to do, but this is much more like optimized in the perspective of cost. So that's how we came up with this two solution. uh is this clear, like these two architecture, or you guys have any doubt?
Yes, it's clear.
No doubt. uh, I, did I explain that well? And others, you guys have like much more clarity, like how this.
Uh, Deepak, like for ECS, and if you see compare with the EKS,
Hmm.
to optimize the cost, we are using the ECS. There is no other difference, right?
Yeah, basically in EKS, if you see na, you need to deploy any worker node. I'm not sure if you are familiar with EKS, like how much you are familiar, how much deep you have gone through. But in EKS, you need to deploy worker node. Worker node is nothing but the compute you are basically occupying. And we have a discussion like the application might have very less traffic, or that traffic, like I believe this EKS will be much more useful for you when you have a microservice kind of architecture, and your architecture have a two, like more than 5 4 services interaction is going on. At that time you can use that whole worker node compute capacity at the optimal way. So let's say you have spent 4 V CPU and 8 GB memory of worker node, two worker node, and you are not utilizing the whole compute or whole memory of both the worker node. So you are paying extra for those uh, nodes, and you are not utilizing from. So you have seen this cost comparison, so you will be paying extra money for, since early cost, when you spin any compute on demand, there is a on demand charges will be there. So this is the only
Yes.
perspective we need to discuss it with like Shrikant, like which flow like he wants us to implement. The whole idea is that this, from cost perspective and the traffic they have told us, that's why I believe, because I have deployed this ECS service for multiple clients for the same use case, the use case they have provided us, like the application will we have much more smaller scale, and paying extra for not using that compute is not ideal for me. Like I believe
Yeah.
yeah.
So Deepak, here you guys have came with the idea of pay as you go model. Like instead of going to the EKS, which have some overhead management of Kubernetes and all. So ECS is like Amazon's collaboration. So it will help us to achieve the optimization. Am I right?
No, pay as you go is applicable for all of the workload. Like when you are going into ECS kind of deployment now, so there is hourly charge associated with each compute you are occupying. Let's say you are spinning any application and you have told ECS service that this application will this small single microservice without any replica. Replica means this application will have two instances, this instance 1 and instance 2. Like these are exactly same, identical, but to since your traffic is scaling out, you have made this two replica, and your traffic will get managed and will routed to both of them, either in round robin way or uh, in any way. Like but them that concept, the pay as you go will have same impact on Fargate and this Kubernetes EKS cluster. But the more important thing is that they told us that their applications will have much lesser traffic. So let's say if you spin any EKS cluster and you have spent this, let's say 4V CPU and 2 memory, 8 GB memory, and this, let's say 4V CPU and 8. So considering the scale they have told, I believe you will hardly reach the limit of this 4V CPU or this. And if let's say you somehow occupied or utilize this whole compute of this node is extra for you. This 4V and 8V, like for this whole stack, whole compute, you are providing extra. So we can go for this target based deployment. So in this you can basically specify up to minimum of 0.V CPU, and maximum it is I believe 4 or 8 V CPU you can go for a single pod, for a single application microservice. And obviously you can replicate it to maintain like highly available system, kind of that. The only important thing is that for cost optimized way, or for another thing is that traffic you will be uh, like getting at the starting very low traffic, since the product is just going to live. So considering both two facts, and the management cost on overhead, the EKS you have to manage, so all of those things, Fargate is the best option. You don't need to manage anything, any patching, all of those things. You just need to provide the configuration of your application unit, and proper CPU and memory utilization you need to provide, and according to that you can deploy that application to the Fargate, ECS Fargate. uh, this is the only two factor. And obviously from learning purpose, obviously you can do deploy on the EKS and look for like how the deployment goes in EKS, and how observability or like how Argo CD works in EKS based deployment. But these are two architecture we have created which we can follow.
Okay,
Is that
Deepak, understood. Yes, yes.
yeah? Anything else? Okay. So if you guys don't have any doubt, we can we can drop from the session. We can end this session, and
Ye-
we'll communicate with Shrikant like how to proceed like this thing, because we also don't have much clarity like how to proceed this thing. So which kind of deployment you guys like we have to show you like how this thing is working. We'll get clarity from him and we'll proceed with that.
Sure, Deepak, sure.
Also, like also I want to understand like do you all of you guys are familiar with AWS, like how much or you are not, so we can better be prepared. Like any few services or the networking, is there any like you guys are familiar or we need to cover those things also step by step? Because teaching from the mid will you will be not having that much clarity.
I am having some exposure, like in the rate in on the scale of 10 to in the 10, I can say it's 7.5 to 8. And the services I have covered is like EC2 VPCs, application load balancers, EKS, and then Lambda functions, S3 storage buckets, and all.
And in EKS, how much deep you have gone?
EKS cluster, I have means a knowledge that what is processing on in the background, those worker nodes, control plane, replicas deployment. I have a knowledge, and I can create the deployment files, YAML files also.
Okay. And ingress, how to expose any application?
Uh, we are currently using application load balancer, so we have to first patch it to expose the application via for the external world. We have to use the load balancer. Like in EKS or in Kubernetes, it's already by default it's a node port or cluster IP.
So have
For
you
to
done like expose any application through load balancer controller, like load balancer? Uh,
yes, you via YouTube tutorials I have,
okay. Okay, got it, got it.
and
Okay.
then yeah,
Okay, for rest, if you're not like not aware, there's no issue. We'll cover and we'll like discuss with Srikanth how to proceed and which architecture should we proceed, and we'll create some task and we'll discuss things and then we'll distribute like how to approach this problem statement, how to solve this. We'll share a few of the resources so that it will be helpful for you. Then we'll come, then we'll review, like all those kind of stuff we can do. But we need to discuss it with Srikanth, like how to proceed, which architecture we should proceed, so that you guys will get like better experience of learning. Okay, I think we are good. If anyone don't have any
yes,
issue, we can drop for today. Thanks for joining, everyone.
yeah. Thank you.
If you want to add anything?
Yeah, hello. So as Deepak has like covered everything which we wanted, right? But the thing is that this the roadmap plan will be like decided once we discuss this with Srikanth, right? So as per that, like we have done the both the setup like with the EKS and ECS for multiple clients. But as per your requirement, I think ECS is suitable. But the thing is, we need to discuss this thing with Srikanth, right? So then only we'll proceed with that. Uh, right, guys? Hello?
Yes, Ayush.
Yeah. Okay, I think we are good. We can wrap up the call.
Yeah, okay.
Okay. Bye bye. Good night.
Yeah, bye.